Hi, I'm Colin, and in this video we're going to talk a little bit about high availability, what it is, and why businesses care so much about it. So, high availability really means that your IT systems will continue to function in the event of some type of failure or some component of that system goes down. So, why is this important? Well, first let's talk a little bit about what causes downtime or outage events. So we can see here, a large percentage, or roughly 45% of downtime is human event driven. So planned downtime, maybe our IT administrators want to upgrade the software or upgrade the host servers. That's a large facet of this. So we need to ensure that our systems can tolerate planned downtime. But then beyond that, we'll also have things like errors or unexpected events. Maybe someone inadvertently puts a typo in a configuration file, or maybe someone accidentally disconnects a network cable, or even, in the most extreme, maybe a server fails because there's a fire in the data center or some electrical grid outage. Any number of events. But really, the important takeaway here is that downtime is an inevitability. So we need to figure out how to build systems that can tolerate those types of events. So what are some of the impacts of unplanned downtime? Well, obviously, first and foremost, loss of revenue or loss of productivity. So if you are a user that cannot access your service that you're paying for, maybe you have a QuickBooks subscription or TurboTax, or maybe you're someone that's very commonly ordering rides off of Uber. So any one of these systems, if you are unable to launch the service and interact with the application in its intended capacity, then you're unlikely to continue to be a user of that system. And obviously availability is integral for mission critical type systems like 911 dispatching and hospital systems, intake, etc. But then also, nowadays in our modern world, almost every business has some software component. It's definitely not an over-exaggeration to say that every company has gradually become, in some degree, a software company. So with this in mind, we want to make sure that our users have good user experience in our application, and especially so with our mission-critical type use cases. So how do we measure downtime? So in the tech industry, really, we call this, or we measure this in nines. So you'll commonly hear, 3.5 or 4.5 nines, 3.5 nines being 99.95. And we can see here that equates to roughly 4 hours and 23 minutes of downtime in a given year. So really, it's kind of a simple calculation here, and most commonly you'll see somewhere between 3 and 5 nines in industry. But again, it's not unheard of to have 6 nines or something that is, incredibly robustly designed and configured to give its end users guarantees of availability. So, maybe financial trading systems really need to have high levels of availability. Maybe airplane routing systems with GPS coordinates, etc. And then maybe you have a service that can tolerate a little bit more downtime, a little more flexibility, like a grocery delivery service or something to that effect. But anyway, in industry we measure these in what are called nines, and typically these come in what are called service level agreements, or SLAs. So if a provider were to breach or go over their guaranteed availability or uptime windows, then they would have some level of compensation or something that they would give back to their end users for breaching that time period. So now, how do we design highly available systems? Now, I don't want to go too deep in this video, but really, what we're talking about for the most part when we're talking about high availability is fault tolerance, and commonly a component of that is replication. So, in this example, we can see we have an application, and it is pointing to two data centers, and we can see in each data center that these are, identical configurations or constructions of the back end. So really, what we're doing here is maybe a plurality of our users go to data center 1, and then maybe data center 2 is just on standby. It's still copying all of the data, all of the inputs from the users that the data center 1 is getting, but then in the event that data center 1 goes down, it can automatically be failed over to or stood up to take that load, and vice versa. Data center 2 goes down, data center 1 comes up. So this is a very common way that we will see highly available systems designed. Now, there are other components beyond just replication. So, in this middle layer here of the pyramid, we'll have an application, and we'll have availability modes. We'll have, standby for secondaries that we might be replicating to. But then we also have a component that is called disaster recovery, or DR for short. And really, this is talking about backups. So, maybe we have a very highly available system. We're replicating to multiple data centers, and something could still go down or take those connections down. So we want to make sure that we have backups that we can very quickly stand up a new server, physical or virtual, and restore from backups to get everything back up and running. So that's, backups are a very important part of your availability plan. And then finally, on the bottom layer here, we see infrastructure as a service, platform as a service, and software as a service. And this is kind of where you get those SLAs that I'd referenced earlier, where these are cloud provider guarantees, where, hey, if you're paying someone for a service, then you would expect some level of redundancy, some level of availability for your application. So that is a quick summary of high availability. Hope you enjoyed. Thanks.